Hello friends, welcome to this YouTube channel. Today we are going to solve a couple of numerical problems on resistance. By solving these problems, we shall learn how to calculate resistivity or conductivity of the conductor material, length or cross-sectional area of the conductor for a known resistance when the values of other parameters are provided. When temperature remains unchanged, the resistance of a conductor is directly proportional to its length, that is, R is proportional to L. It is inversely proportional to its area of cross-section, that is, R is inversely proportional to A, and it depends upon the nature of material. Now we can write R is proportional to L by A. Therefore, R equals to rho into L by A, where proportionality constant rho is termed as resistivity of the material or specific resistance. When L equals to 1 meter and A equals to 1 square meter, R equals to rho. Hence, specific resistance or resistivity of a material is the resistance offered by 1 meter length of wire having an area of cross-section of 1 square meter. Reciprocal of resistance is termed as conductance. G equals to 1 upon R, that is equal to 1 upon rho into A by L. This may be written as sigma into A by L, where reciprocal of resistivity sigma is termed as conductivity. The resistance of a 40-meter long conductor is 0.68 ohm. It has a cross-sectional area of 1 square millimeter. We have to determine resistivity and conductivity of the material. Let us first write down the given data. Resistance of the conductor R equals to 0.68 ohm. Length of the conductor L equals to 40 meters. Cross-sectional area A equals to 1 square millimeter, that is equal to 1 into 10 to the power minus 6 square meter. Expression for resistance of the conductor R equals to rho into L by A. Therefore, expression for resistivity of the conductor material rho equals to R into A by L. Using values we get 0.68 into 1 into 10 to the power minus 6 divided by 40. That gives us 1.7 into 10 to the power minus 8 ohm meter or 1.7 micro ohm centimeter. Conductivity of the conductor material sigma equals to 1 upon rho, that is equal to 1 upon 1.7 into 10 to the power minus 8. That gives us 58.82 into 10 to the power 6 mho per meter or 58.82 mega mho per meter. A 50-meter long conductor takes 2.5 ampere when connected across 50 volt DC supply. It has a cross-sectional area of 5 square millimeters. We have to determine resistivity and conductivity of the material. Let us first write down the given data. Applied voltage V equals to 50 volts. Circuit current I equals to 2.5 ampere. Length of the conductor L equals to 50 meters. cross-sectional area of the conductor A equals to 5 square millimeters, that is equal to 5 into 10 to the power minus 6 square meter. Let us first calculate resistance of the conductor R equals to V divided by I. Using values we get 50 divided by 2.5, that gives us 20 ohm. Expression for resistance of the conductor R equals to rho into L by A. Therefore, resistivity of the conductor material rho equals to R into A by L. Using values we get 20 into 5 into 10 to the power minus 6 divided by 50. That gives us 2 into 10 to the power minus 6 ohm meter or 2 micro ohm meter. Now we shall determine conductivity of the conductor material. Sigma equals to 1 upon rho, that is equal to 1 upon 2 into 10 to the power minus 6, that gives us 0.5 into 10 to the power 6 mho per meter or 0.5 mega mho per meter. We have to determine the cross-sectional area of a conductor of 1 kilometer length to transmit 200 ampere so that the total voltage drop in the conductor may not exceed 12 volts. The resistivity of conductor material is 3 micro ohm centimeters. Let us first write down the given data. Resistivity of the conductor material rho equals to 3 micro ohm centimeters, that is equal to 3 into 10 to the power minus 8 ohm meter. Length of the conductor L equals to 1 kilometer, that is equal to 1000 meters. Maximum allowable voltage drop V equals to 12 volts. Circuit current I equals to 200 ampere. Let us now determine resistance of the conductor. R equals to V divided by I. Using values we get 12 divided by 200, that gives us 0.06 ohm. Expression for resistance of the conductor R equals to rho into L by A. Therefore, cross-sectional area A equals to rho into L by R. Using values we get 3 into 10 to the power minus 8 into 1000 divided by 0.06. That gives us 5 into 10 to the power minus 4 square meter or 5 square centimeters. A 0.7 meter long heating element absorbs 1250 watts when 5 ampere current flows through it. We have to calculate diameter of wire cross section when resistivity of the material is 110 micro ohm centimeters. Let us first write down the given data. Resistivity of the material rho equals to 110 micro ohm centimeters, that is equal to 110 into 10 to the power minus 8 ohm meter. Length of the wire L equals to 0.7 meter. Absorbed power P equals to 1250 watts. Circuit current I equals to 5 ampere. Let us now determine resistance of the wire. R equals to P divided by I square. Using values we get 1250 divided by 5 square, that gives us 50 ohm. Expression for resistance of the wire R equals to rho into L by A. Therefore, cross-sectional area of the wire A equals to rho into L by R. Using values we get 110 into 10 to the power minus 8 into 0.7 divided by 50. That gives us 1.54 into 10 to the power minus 8 square meter or 0.0154 square millimeter. Expression for cross-sectional area of the wire A equals to pi by 4 into d square. Therefore, diameter of wire cross-section d equals to root over 4 times A divided by pi, that is equal to root over 4 into 0.0154 divided by pi, that gives us 0.14 millimeter. The specific resistance of platinum at 0 degree centigrade is 10.5 microohm centimeter. We have to determine the length of platinum wire of number 32 SWG to have a resistance of 8 ohm at 0 degree centigrade. Given diameter of the wire 0.0274 centimeter. Let us first write down the given data. Specific resistance of platinum rho equals to 10.5 microohm centimeter, that is equal to 10.5 into 10 to the power minus 8 ohm meter. Resistance of the wire R equals to 8 ohm. Diameter of wire cross section D equals to 0.0274 centimeter. Let us first determine cross-sectional area. A equals to pi by 4 into d square, that is equal to pi by 4 into 0.0274 square. That gives us 5.8965 into 10 to the power minus 4 square centimeter, that is equal to 5.8965 into 10 to the power minus 8 square meter. Expression for resistance of the wire R equals to rho into L by A. Therefore, length of the wire L equals to R into A by rho. Using values we get 8 into 5.8965 into 10 to the power minus 8 divided by 10.5 into 10 to the power minus 8. That gives us 4.4926 meter. A coil of copper wire having a cross-sectional area of 0.34 square millimeter when connected to a 100 volt DC source draws a current of 5 ampere. If the resistivity of copper is 17 microohm millimeters, we have to calculate the length of the wire of the coil. Let us first write down the given data. Resistivity of copper rho equals to 17 microohm millimeters, that is equal to 17 into 10 to the power minus 9 ohm meter. Applied voltage V equals to 100 volts. Circuit current I equals to 5 ampere. Cross-sectional area of the wire A equals to 0.34 square millimeter, that is equal to 0.34 into 10 to the power minus 6 square meter. Let us first determine resistance of the wire. R equals to V divided by I. Using values we get 100 divided by 5, that gives us 20 ohm. Expression for resistance of the wire R equals to rho into L by A. Therefore, length of the wire L equals to R into A by rho. Using values we get 20 into 0.34 into 10 to the power minus 6 divided by 17 into 10 to the power minus 9, that gives us 400 meters. A current of 0.5 ampere is passed through a coil of nichrome wire which has a cross-sectional area of 0.01 square centimeter. If the resistivity of nichrome is 108 micro-ohm centimeters and the potential difference across the edges of the coil is 54 volts, we have to determine the length of the wire, the conductivity and conductance of the wire. Let us first write down the given data. Resistivity of nichrome rho equals to 108 micro-ohm centimeters. That is equal to 108 into 10 to the power minus 8 ohm meter. Cross-sectional area A equals to 0.01 square centimeter, that is equal to 0.01 into 10 to the power minus 4 square meter. Potential difference V equals to 54 volts. Circuit current I equals to 0.5 ampere. Let us first determine resistance of the wire. R equals to V divided by I. Using values we get 54 divided by 0.5, that gives us 108 ohm. Conductivity sigma equals to 1 upon rho, that is equal to 1 upon 108 into 10 to the power minus 8, that gives us 92.59 into 10 to the power 4 mho per meter. Conductance G equals to 1 upon R, that is equal to 1 upon 108, that gives us 0.00926 mho. Expression for resistance of the wire R equals to rho into L by A. Therefore, length of the wire L equals to R into A by rho. Using values we get 108 into 0.01 into 10 to the power minus 4 divided by 108 into 10 to the power minus 8, that gives us 100 meters. So today we have solved a couple of numerical problems on resistance. By solving these problems, we have learned how to determine resistivity or conductivity of conductor material, length or cross-sectional area of the wire for a known resistance when values of other parameters are given. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.